In the previous video, we learned about task structure. In this video, we will see this in practice. In this video, I'm going to demo task next to our previous demo code for I/O so you can see how beautifully functional paradigm abstracts synchronicity. First, let's define task structure. Task similar to I/O models computation. I/O models synchronous computation, while task models asynchronous computation. So when it's triggered, it's going to deliver us promise of A. Next, let's add boilerplate code for task. So we say interface URI to kind. We extend this interface task A. We already know task is a functor, so let's define functor instance for it. Let's come over here, and you know what? Let me scroll a little bit. So const task functor 1 of task, and now we're going to, let's add the URI first, task, and let's implement the map function. Map receives function f from A to B. It then receives task A, and finally it should return task B. How can we get to this task B? We can call task A first. It returns a promise, so we can say then, and we now have access to value A, and then we can call F with that value. And finally, we need to wrap this in a tongue. Another thing we can do is, this is redundant, we can just mention F. Now that we have a functor instance for task, let's look back at our I/O example. Roll dice is of type I/O of number. It means it's a computation that finally delivers us a value of type number. The way it does that is by doing a side effect of getting a random number between 0 and 1 using a math API. It scales that to 6 by multiplying it to 6, and then getting a next round number, and finally wraps it in a tongue. Let's have a similar example, but instead of having this synchronous random function, let's say our random function is asynchronous. For example, let's say we have a math server which it has a random function on it. So random is a tongue function that when it's called, it's going to return us a promise of math.random. Now let's first rename this roll dice to roll dice sync. And let's define our roll dice async now, which is of task of number. Const roll dice 2. Now this time is roll dice async. The way it works is it's a tongue function. We're going to call random methods on math server. This gives us a promise that delivers us a random value. Now we're going to scale this to a value between 0 and 6 and call math.sale on top of it. Now that we have our asynchronous roll dice 2, for our isEven, it's going to be the same. IsEven receives a number and returns a Boolean value indicating that if a number is even or not. The next thing we want to do is we're going to define this task is even and task console log, similar to I/O is even and I/O console log. Let's do this right here. Const task is even. We're going to lift is even to task using task functor .map is even. Let's make some space here. And now let's define task console log, task functor, and we're going to lift our console log. And finally, let's define our program. Const program 2. So what we want to do is we want to roll a dice asynchronously, then check if the value is even, and finally console log it. So we're going to roll our dice asynchronously, check if it's even using task is even. Let's look at the type. Now we're getting a task of Boolean as we expect, and now we want to console log it. So we say task console log, and we have our program 2. Let's change this to program 2, and if I save, we get false, true, true. If I save again, we get true, false, false. If you look at program type is of type IO avoid. If you look at program 2 type is of type task avoid. One is synchronous and another one is asynchronous. But when we look at the implementation, no more async awaits, no more .then .catch. They look pretty similar. We first roll the dice, then we check if it's even, and finally we are console logging it. And that is one of the benefits of coding functionally. What we did is we abstracted synchronicity, so we don't need to worry about it anymore. And with that, thank you for watching this video. Please like and subscribe, and I will see you in the next one.